Hi guys, today we're going to take a look at page 14 of your Unit 2 classwork packet. The topic in question is going to be rotations about other points besides the origin. Now, if you'll recall, earlier we took a look at dilations that were not centered at 0, 0, right? In order to perform those, we first had to write the vectors and then we dilated the vectors. The same thing is going to apply here, only once we rotate the vectors, then we're going to apply them back to the center of rotation. So these are really two sides of the same coin. The only difference is in the formulas that I'm using. With dilations, I would multiply the vector by something. In this case, I'm going to apply my coordinate rules to the vectors. Let's take a look at an example together. Page 14, the big example, or it just says example, all right? So first things first, let's get our triangle graphed, okay? So we've got ourselves a little triangle here. So 4, comma 7, 4, 1, 2, 3, 4, 5, 6, 7. All right. We've got 8, comma 5, 5, 6, 7, 8, 1, 2, 3, 4, 5. And then we've got 6, comma 3. So 3, 4, 5, 6, and then 1, 2, 3. Okay, so I've graphed my triangle, and what I'm also going to do is I'm going to graph my center of rotation. And in this case, my center of rotation is 1, comma 2. So I'm going to write that right here. Okay, excuse me. All right, so what we're going to do is we're going to start this off exactly the same way as we did the dilations. Step 1, let's write our vectors. So from 1, comma 2 over here to 4, comma 7, that's going to be right 3 and up 5. Right 3, up 5. If you don't believe me, just count 1, 2, 3, and then up 1, 2, 3, 4, 5. Okay, let's try it for the next one. So I'm going to go 1, 2, 3, 4, 5, 6, 7. Is that right? 7 to the right. And then 3 up. Did I say 3 up? Yeah. Sorry. 1, 2, 3, 4, 5, 6, 7. I can't count today. And then 1, 2, 3 up. All right. So I'm going to write that as a vector 7, comma 3. Last but not least, sorry, I hope I'm not in your way there. In order to get from 1, comma 2 to 6, comma 3, I got to go 5 to the right, and I got to go 1 up. Let's make sure I'm right about that. 1, 2, 3, 4, 5, and 1 up. So far, so good, right? Now, this is where it's going to vary slightly from what we did before. Previously, when we dilated, we would just multiply through by the scale factor. Now, we actually got to use our coordinate rule for the rotation in question. So in this case, the rotation is a 90-degree counterclockwise. So let's think. What's the formula for a 90-degree counterclockwise? Well, it's none other than negative y, comma x. So what I'm going to do is I'm actually going to take that formula and I'm going to apply it to each one of these vectors. Let's do that now. So everything that was in the y column is going to come to the front and it's going to change in sign. So let's write my new vectors now, okay? So I'm going to start with negative 5, negative 3, and negative 1. And then whatever used to be first is just going to get put in the second column. So my 3, 7, and 5. I'm going to be very careful here. I kind of did something very bad. I want to make sure I remember that these are still vectors, okay? Now, what I'm going to do with these vectors, I'm going to apply them to the center of rotation. How exactly I'm going to do that? I'm going to write my center of rotation up here, and I'm going to use orange to be consistent, okay? So my center of rotation was 1, comma 2. So let's apply this one first, okay? So 1 minus 5, that's going to give me negative 4. 2 plus 3 is going to give me 5. All right, 1 minus 3 gives me negative 2, and 2 plus 7 gives me 9. All right, so these two are done. Last but not least, 1 minus 1 is going to give me 0, and 2 plus 5 is going to give me 7. So now, let me actually take a look and see what that's going to look like on the graph. So 1, 2, 3, 4, 1, 2, 3, 4, 5, okay. Then negative 2, 1, 2, 3, 4, 5, 6, 7, alrighty, and then 0, 7. 1, 2, 3, 4, 5, 6, 7. Alrighty, so notice, right? It's pretty much, well, not pretty much, it's the same figure. It hasn't changed in size because we're talking about a rigid motion transformation, right? The only thing that's changed about it is that we have done a rotation about this point instead of around 0, 0. So let's refresh here. When I have to do a rotation about a point other than 0, 0, step 1, make the graph. Step 2, write my vectors. Step 3, apply my coordinate rule to the vectors. And step 4, make sure that you then do the vectors on your center of rotation.